So here's what we're doing today. We're going back to one more thing, one last thing. We're still talking about vertical asymptotes. We're still talking about horizontal asymptotes. The big difference today is yesterday, everything we were doing was based on the problems that we had where that it was just 1 over some number or 6 over x or something like this. For the ones we're doing today, everything is more complicated. The denominator is not just going to be x or x plus 2, x minus 3. Now we're actually looking at being bigger expressions where maybe we've got x squared, we've got x to the third, we've got something like that. So, all right, so the very first thing we've got vertical asymptotes, but still the same thing as yesterday. What we're going to do today with vertical asymptotes is vertical asymptotes, they occur where the denominator is equal to 0. Same thing we did yesterday. Says if you're able to factor something from the numerator and the denominator, it actually creates a hole in the graph. So instead of it being like an asymptote, like we drew the line and said you wouldn't touch it, get close to it. If you've got something you can cancel out of numerator and denominator, like an x plus 2, then there's a actual hole in the graph at x plus 2 equals 0. So it actually like skips over to it. All right, now here's the big thing. Here's the big change for this one. Jaden. Horizontal asymptotes. These, and it's not just a cut and dry situation with horizontal asymptotes now. These are based on the degree of the numerator, which we're going to call m, and the degree of the denominator, which we're going to call n. Okay. And if your numerator degree is less than your denominator degree, it's just like we were doing yesterday, the horizontal asymptotes at y equals 0, right on top of the x-axis. If the two things are equal, if the numerator is x to the third and the denominator is x to the third, then your horizontal asymptote is going to be basically where you would divide the first term, the leading coefficient, wherever you pulled your m value from in this one, and then you simplify those two numbers. So it should be like 3x to the third over 5x to the third. So your horizontal asymptote would be at 3/5. Okay, and then the last one, which we're not going to dig into this a whole lot more, other than just to say that if we have this one, if the numerator is greater than the denominator, there is not a horizontal asymptote. There's a slant asymptote. And we're not going to actually put where that slant asymptote is, because if to do that one, we would have to do synthetic division and work the problem out and then go back and figure out where it would be. But we're not going to do that. We're just going to basically going to say that there is no horizontal asymptote. So we're either going to have one at 0, one where it's going to change, or there's none at all as far as horizontal asymptotes go. All right, so here we go. We're going to walk through these and make sure we kind of understand what's going on. And then we'll actually take 2 problems, and we're going to graph those 2 problems and show you how a graph would look like when we tie all this stuff together. But this first part, we're just finding out what the asymptotes are going to be. All right, so number 1, we've got f of x is negative 2x plus 6 over x minus 5. So if we start checking things out, in this case, what's the degree of the numerator? It's x to the first power, right? Because basically, if you don't have a power there, it's understood to be a 1. And denominator, same thing. It's also 1. So if these 2 things are equal, and we're talking about the horizontal asymptote here, then the numerator and denominator, those 2 things are equal, which means now the horizontal asymptote by default is going to be where we put these, basically put the first 2 terms over itself. Okay, so basically we're going to have it be at negative 2x over x. And if the degrees are the same, of course the x's are just going to cancel each other out. And whatever coefficients you have left over, that's going to be what your horizontal asymptote is going to be. So you're going to have a horizontal asymptote at y equals negative 2. Because it was negative 2, because it's negative 2x over x. So if you cancel out the x's, it's negative 2 over 1, which is basically just negative 2. All right, and your vertical asymptotes. This is just, and this is usually the easy part, it's just your denominator. equal to 0. And that one really easy. It's just x equals 5. Okay. Everybody all right with that one? All right, for example 2. The numerator has x to the first power, basically your leading term there. So it's x to the first power, so your degree is 1. In your denominator, it's x squared, so your degree is 2. And it's always the first, m is always the first number. So you've got 1 that you're going to compare with 2. In that case, 1 is less than 2, right? So that one works out pretty nice because since 1 is less than 2, then by default, it's going to go back to y equals 0. So we've got a horizontal asymptote at y equals 0. Okay, vertical asymptotes. And here's where it's kind of a good review right before we get close to final exams here. You've got to take your denominator and set it equal to 0. Which means we get to do what with that denominator? Yeah, we get to factor. So we got to find the factors of negative 12 that equal positive 1. All right, negative 12. All right, so we need the factors of negative 12, and we need the sum to equal positive 1. Okay, it's not going to be 1 and 12. It's not going to be 2 and 6. It's going to be 3 and 4. And because the b term is positive, that sign always goes with the bigger number. And to find the sign of the other number, you just divide these two numbers. It's negative 12 divided by positive 4. That means the 3 is going to be a negative. Okay, so that leaves us with x minus 3 and x plus 4. And setting both of those equal to 0, which again is really not hard at all. That's x equals 3 and x equals negative 4.
What's that finish for the two factors? Is that negative 1 or 1?
That's supposed to be right here.
Yeah.
It's supposed to be a negative 12. And then each, and then we'll look for the sum equal to positive 1.
So would they have given us 2 blanks for the x's? Or would they say like pick 1? Like how would we know what to do?
Oh, we'll show you how to do that here in a minute. So we're going to show you how to graph that where you got 2 asymptotes. Okay. All right. So number 3, same thing here. We'll go for the horizontal asymptotes. Again, it's all based on the degrees of the powers. You've got x squared. So your numerator is degree 2. You've got x to the first. So that's numerator degree 1. And if you compare those two numbers, 2, again, it's always the m first and the n second. 2 is greater than 1. And if m is greater than n, there is no horizontal asymptote. There's only a slant asymptote. So we'll say that there's none. Which means for a problem like that, I'm not going to ask you to graph that one because we'd have to add in the slant asymptote, and that's, we can still do that, but we'll let pre-cal save you for that one. So. Because it's not that big a step from here, but we'll save that for pre-cal.
So m can't be bigger than n, but n can be bigger than m.
If we're looking for horizontal asymptotes, correct. All right, vertical asymptotes. This one, pretty easy. It's just x minus 4 equal to 0. So it's x equals 4. Okay, and then the last one for horizontal asymptotes, again, your numerator is degree 1, denominator is degree 2. So again, if we compare m and n, that's 1 and 2. 1 is less than 2, and if we do that one again, if m is less than n, default, we're going back to y equals 0. All right, for your vertical asymptotes. X squared plus 5x equals 0. Again, good review for graphing on this one. So we're going to graph this thing. Sorry, factor. What do we do to factor this thing? Actually, that's for trinomials. So this one, there's 2 terms. So yeah, so with 2 terms, you always look for a greatest common factor first. They both have an x, so we can take the x out. And if you take the x out that they both have in common, well, now you've just got it factored as far as it can go. So now you can do x equals, set x equal to 0, x plus 5 equal to 0. So again, we've got 2 asymptotes. One's going to be at 0, and the other's going to be at negative 5. Okay, so everybody okay just finding the asymptotes? Okay. All right, now here's where we're actually going to graph 2 of these. And you've probably got room if you run out of paper. You can do it on the back of this one. I'm going to just put it on line paper just so it's easier for me to kind of keep up with it. But, it's your choice there. So here's what we're going to do. All right, we're going to find the horizontal asymptotes and the vertical asymptotes. And we're going to sketch the graph. Okay, so just go different on this one. We'll go example A today. Make Emma happy. Okay, so let's go with y equals 2x plus 3 over x minus 5. We'll give you one that's pretty straightforward, pretty easy. We'll give you another one that's a little more complicated. Okay, again, for horizontal asymptotes, that's where we're going back to this part where we're going to compare the degrees of the numerator and denominator. So this one, numerator is degree 1. Denominator, also degree 1, which means they're both equal, because 1 equals 1. So in that case, we're going to take the first 2 terms we've got here and basically just put those 2 things over each other. So just do 2x over x. And again, by doing that, the x's cancel out. It just leaves you with a coefficient. So that's really 2x over 1x, or just y equals 2. Okay, so horizontal asymptote, again, just got to compare. And then based on what the values are for the degrees, it tells you what type of horizontal asymptote you're going to have. All right, vertical asymptotes. Still just denominator equal to 0. So that's x minus 5 equals 0. And that's pretty easy. That's x equals 5. All right, so we go to graph this. Now we know we're going to have basically this is telling us where we're going to shift the graph. We're going to shift it over to x equals 5, then up to y equals 2. So when you graph this thing, we're going to go over to x equals 5, go up to y equals 2, and basically that's like the new center of our graph that we've got right there. And we're going to draw a vertical line at x equals 5. And we're going to draw a horizontal line at y equals 2. Okay, now, and it's not just as simple. Now, the easy thing was when we were doing these yesterday, all we had to do was look at the top number. If this number was just 3, we knew the graphs were going to be here and here. But that extra variable kind of throws things for a loop, because what happens if this x is negative and this x is positive, or both of these are negative, or both of these are positive? It kind of depends on what numbers we're plugging in. So here's what we have to do. You're going to have to, and we're going to do this in this corner down here because we're not going to do much here. You're going to have to plug in values, or a value. On each side of the vertical asymptote to determine where the graph goes. Because what we were saying yesterday is that when we're drawing these asymptotes, it's like a fence. So, this is your house, this is your neighbor's house, this is your other neighbor's house, you got another house over here. So that basically you've got to figure out, okay, where is my house? If we're plugging in these values, you're trying to figure out which yard this thing is going in. So either we're going to be here. So basically, when we plug in this part of it, on every side of the asymptote, we're trying to figure out, is the graph up here or is it down here? And on this side of it, we're trying to figure out, is it here or here? And to do that, we just pick one number on either side of the vertical asymptote. So we've got x equals 5. Well, an easy number to plug in is the number right beside it. Let's plug in x equals 4. And then when we plug in x equals 4, it's either going to be above the line or it's going to be below the line. And that way we're going to know which way this graph is going to be, where it's going to land up. Okay, so we're going to take x equals 4 and we're going to plug it back into this original equation that we got and just see what happens with it here. Oh, so that if because this is our asymptote that's right here for a vertical asymptote, that if we pick 4, that graph point either has to be here or here. And then if we go over here to like x equals 6, same thing. That point's either going to be here or here, and it's basically going to kind of tell us where it's going to be. So if you pick one right beside the vertical asymptote, it's going to tell you whether it's up or down based on what number it is when you plug it back in. Okay, so first thing is we're going to plug in x equals 4 and see where that point goes. So we've got x equals 4, and we're going to plug that into y equals 2x plus 3 over x minus 5. Plug it in here and plug it in here, and then just see what happens. So that's 2 times 4 plus 3 over. In that case, there's nothing else you got to do with that x when it's there. It's just that number minus 5. So that's 8 plus 3 over negative 1. So that puts that x value of 4 at 4. That gives us a y value of negative 11. So that ordered pair is at 4, negative 11. So all you got to do then is basically just plot where that point is. And again, it's either above or below the line. 4, -11 would put us, here's 4, -11 is going to be way down here somewhere, which means for that particular graph, it's got to stay in, and again, this is your fenced area that's here. It's got to stay within that fenced area. So that means no matter what it's going to do, it's going to be in here somewhere, something like that.
So we use the original graph that's given, not our new graph?
Say that question again.
Like we use the original graph they gave us, not.
Okay. So again, you can pick any number of points you want to plug in. So we plugged in x equals 6. We got the point at 6:15. Again, we plotted that point here. And as long as we've got that point here, again, that's in that particular fence, all the points have to be in that yard that's here. All right, let's do one more. Let's see how we feel on it.
Wow. I was thinking of what I.
All right, here we go. So we'll do x minus 2 over x squared plus 5x. All right, and again, easy. The one thing you can do, anytime you get f of x, you can always think that it's just y equals, especially with that we're going to be graphing some points with this one. So even if they give you f of x, just go ahead and think that this is really y equals because it's still basically the same thing. All right, so let's get the easy stuff out of the way first. Vertical asymptote. That is your denominator equal to 0. All right, and we just did this almost exact same problem just a few minutes ago. That you got to factor this, and if there's two terms, question. Just the notation of it. This is an equation, and that's just a function. So they made basically interchangeable. No, same thing. Okay, so for this one, we're going to factor out the x. So we've got x equals 0 and x plus 5 equal to 0. X equals 0 is done. There's nothing you can do with that one. Subtract the 5 from this one, so now we've got 2 vertical asymptotes. Okay, for the horizontal asymptote, again, you're only looking at the leading term, so that's x over x squared. So that's numerator is degree 1, denominator is degree 2. So we're comparing 1 and 2. And again, m is always first. 1 is less than 2. So that default puts the asymptote back at y equals 0. Okay. Everybody okay with that? All right. Now here again, all you got to do then is go ahead and graph those two things you've got. So we're going to draw a xy axis. You're going to put a vertical line at x equals 0. Oh, yeah. I'm going to put that because it's right on top of the axis. I'm going to do that in a highlighter. Okay, so there's x equals 0. Because it's right on, and if we don't do it that way, it's hard to see it because it's right on top of the axis. We also got another one at x equals -5. 1, 2, 3, 4, 5. So that would put that one conveniently right there. Yeah, that worked out really nice. That was right on top of the number that was there. And then y is 0, so that's going to take us on a asymptote that's going to go. No, that's not going to work. That was dying. Make it kind of bold so we can see it there. There you go. Okay, so is everybody okay plotting the asymptotes? Okay. Because again, you're just drawing vertical lines at the x values. You're drawing a horizontal line at the y value. Okay, so this is at -5. This one's at 0. Okay, so all you have to do, everybody's good with that. And this is where you don't have to overcomplicate things. What is a number that's to the left of -5? -6, right? So you just need to plug in -6. And when you plug in negative, because if you're on this side, here's the thing. The asymptote, when you graph these, it's either above or below this asymptote. You either have numbers up here or numbers down here. So you can plug in -6 or -7 or -8 or -9. But we'll stick -6 because most of the time if you pick -6, it's going to be a little easier number to work with. You pick it right beside there. So plug in -6. I'm just going to put that down here so we got plenty of room. And we're going to plug that back into the original equation. And we're going to replace the f of x with y just because it's easier that way. And we're going to plug in that -6 and then just work it out and see what we get. All right, so the y is equal to -6. And because it's a negative, I'm going to put it in parentheses so I don't mess anything up when I plug this thing in. Over -6 squared plus 5 times -6. And if you're one of those people that's bad about messing stuff up, I would say every time you plug in a number, whether it's positive or negative, put it in parentheses because that should make your life a little bit easier. Especially if you're going to use a calculator to evaluate it. It should make your life really easy because you can plug this in to find out what your numerator is, and then you can plug that in to find out what your denominator is, and then you've got the fraction that you need. If you've got a good enough calculator, Casio's, you can plug that whole fraction in and it will tell you what the answer is without having to work through that. But we're going to do it by hand here. -6 minus 2 is -8. -6 squared is 36. 5 times -6 is -30. So that is -8 over 6, which is -4 thirds.
-6 times -2.
-6 minus.
Minus 2.
Yeah, -6 minus 2. Sorry. All right, and you're like, how are we going to graph that? We're not. Remember, fractions, we're not worried about that because all you need to do is just plot roughly where that point is. So this would be the point at -6 and -1.3, right? Because we plugged in x for -6, we got an answer of -1.3. Just plot that point. -6, -1.3. Everybody okay, is that somewhere about there? All right. So we're only looking at everything over here, which means if that point is here, every point is going to be in here somewhere. So that graph is going to do something like that. Because again, those are fences, and once you're inside that fence, you cannot get out. I hate to say that, but that's kind of what we're doing here. So that when you're graphing this thing out on the edges out here, you're kind of stuck there. Now, if it'd been like, if we plugged in -6 and this number was positive 1.3, and that would put us up here, then the graph is up here. So all you're trying to do is figure out where is that one point right beside it, and then we're figuring out what's going on. All right, so is that okay? Does that seem a little better? Okay, now we're also going to do the same thing to the right side of our asymptote here. And again, let's don't make it too complicated. Let's pick the number right beside here. That's going to be at -4. So now we're going to plug in -4 and see what happens. All right, so we're going to plug it in and see what happens here. So we've got -4 minus 2 over -4 squared times 5 times -4. So -4 minus 2 is -6. -4 squared is a +16. 5 times 4 is -20. So that's -6 over -4, which means that's 6 over 4, and that's a 1.5. All right. And again, we're not really, I mean, you're concerned with the number? Do what? Also be 3 over 2, yes. Okay, so this point is at -4, 1.5. And again, if we plot that 1 point, that means every point's either above or below the graph there. So if we go to -4, 1.5, -4, 1.5 is about here, which means that this graph is going to be over here. Now, here's the catch. If we have a middle section like we do here, if we didn't have this third asymptote over here, or this is second asymptote, we could draw this line out and we'd be okay. Now, and the other thing is on this one, sometimes in the middle, this graph can actually jump across because it's a special graph. Now, in this case, it's not going to, but that's where we talked about having like holes in the graph. Sometimes if we have a hole in the graph, there's a hole on the x-axis, and it'll let this graph sneak through. But we didn't have anything that factored out, so this one is probably not going to have any holes. But just to be on the safe side, we're going to plug in -1 and see if it's, and it should be here. It should be basically up here. But we're going to just double check to make sure. Because sometimes graphs behaves a little funny. But we didn't have any holes in this graph because there wasn't anything we could factor and cancel out. So back up here in the beginning, if we had factored this, if we had like an x minus 2 here, or an x plus 5 and x plus 5, if these had canceled out, we actually could have had a hole in the graph right here. This thing could have found a hole and gone through. But we didn't have this to cancel out, so there shouldn't be any holes. So it basically should be that everything is up here. But we're going to double check just to make sure. All right, so we're going to plug in x equals 1 just to see what happens. I'm running out of room on this piece of paper, so I'm going to go to a second piece of paper. And we're going to plug in x equals -1. Again, just plug in that -1 every single time. -1 squared plus 5 times -1. So that's -1 minus 2. -1 squared plus 5 times -1. So -1 minus 2 is -3. -1 squared is 1. 5 times -1 is -5. So that's -3 over -4, which is a positive 3/4, which is basically just 0.75.
Does it stop or does it keep going? Or do you plug in 1?
No, just need 1.
Okay.
Okay, so that's -1.75. And again, as long as there's not any holes in the graph, that point should be in the upper graph. So -1, now it's not very much, but it's right here, which means that this thing is going to come in and turn and do something kind of like that. So it did actually do what we said it was going to do, because that -1.75 was somewhere about here. So that graph is going to look something like that. Okay, and then one last problem, one last number to plug in, because over on the left, far right side, we've got this part of the graph over here. We either need something here or something here.
You have to have something over there?
Yeah, and if we had, and we're going to stop at 2, because sometimes you might actually have 3 asymptotes, which means you'd have more points to plug in. But we're just going to stop at 2. All right, so let's pick the next point right beside this one, which is now going to be 1. All right. So x equals 1. We're going to do y equals 1 minus 2 over 1 squared plus 5 times 1. Negative 1 on top. 1 plus 5 on the bottom. So that's negative 1/6. Okay. Now the big thing is for that particular number, it's negative, right? Doesn't matter what the number is, but it's negative. So that means when we go graph that number, it's going to be really close to the line. But if we do 1, negative 1/6, that point is somewhere about here, which means now, again, basically every time we get here, it's either above or below the line. That's below that line. So every point here is going to be below the line. So something like that. All right, and there you go.